All right, in this video, we're going to talk about 3.2, Objective 2, where we find derivatives of functions using limits. Previously, we found the derivative at a particular point that we had the x value a given to us. We'll be doing that later, but we did not find the generic slope function f prime of x. We found just f prime of a, and then we use that to maybe find the equation of a tangent line. This time we're going to say the limit as h approaches 0 of f of x plus h minus f of x divided by h is our generic slope generating function at any point on the curve. And then we'll be able to stick in multiple x values to be able to get the slope at those individual points without doing the whole limit process every time. So we've already talked about this, but a linear function has the same slope everywhere. I'll do the limit process to prove it to you, but this one is rather straightforward. F of x is equal to 3x. F prime of x is limit as h goes to 0 of 3 times x plus h minus 3x over h. F prime of x is equal to limit as h goes to 0 of 3x plus 3h minus 3x over h. 3x minus 3x will go to 0. Everything in the numerator that doesn't have an h in it will have to go to 0. Some of the h terms may also go to 0 in this process sometimes. So limit as h goes to 0, 3h over h. It's going to be limit as h goes to 0 of the constant 3, which is 3. All right. Let's look at this next one where y is equal to 2x squared. I want to find dy dx, which is going to be the limit as h goes to 0 of 2 times x plus h squared minus 2x squared over h. Take a quick look at how they want this formatted. They want me to expand this. To become, as h goes to 0, 2x squared plus 4xh plus 2h squared minus 2x squared over h. Yeah, that's what they want for this box. So 2x squared plus 4xh plus 2h squared minus 2x squared over h. And then we're going to zero out the non-h terms, factor out my common factor of h from the numerator, and cancel it. Limit as h goes to 0 of 4x plus 2h. Any remaining h terms are going to 0. That leaves me with an answer of 4x for my derivative. I can go ahead and evaluate dy dx when x is 4 will be 4 times 4 is 16. And dy dx when x is -5 is 4 times -5 is a -20. Very good. Okay, let's go ahead and look at number 3. F of x is equal to 6x plus 1. We already talked about the fact that the slope of a linear function is constant. So let's go ahead and show that once more. F prime of x is limit as h goes to 0 of 6 times x plus h plus 1 minus 6x plus 1 over h, limit as h goes to 0, 6x plus 6h plus 1 minus 6x minus 1 over h. 6x and negative 6x make 0, 1 and negative 1 make 0. Limit as h goes to 0 of 6h over h. H's will cancel. Limit as h goes to 0 of 6 is 6. And then since there's no x's left in f prime of x, it's constant. It will be the same no matter what the x value is. F prime of 1 is 6. F prime of 5 is 6. It doesn't matter what x is. F prime is going to be 6. F of x is now 7x squared plus 1. Let's write the limit definition of f prime of x. Limit as h goes to 0 of 7 times x plus h squared plus 1 minus 7x squared plus 1. Wrap that in parentheses over h. F prime of x is limit as h goes to 0 of 7 times x squared plus 2xh plus h squared plus 1 minus 7x squared plus 1. Leave that alone for the first blank. They don't want you to worry about the subtraction yet. Do go ahead and distribute this 7. It's 14 xh plus 7h squared plus 1 minus 7x squared plus 1 over h. I really don't need these parentheses. Let's drop them out. So 7x squared plus 14xh plus 7h squared plus 1 minus 7x squared plus 1 in parentheses over h. Give me f prime of x is equal to limit as h goes to 0 of 7x squared plus 14xh plus 7h squared plus 1 minus 7x squared minus 1 over h. 7x squared and negative 7x squared make a 0. Negative 1 and positive 1 make a 0. F prime of x is equal to limit as h goes to 0 of, let's factor an h out of what's left in the top, 14x plus 7h over h. h's will cancel. Limit as h goes to 0 of 14x plus 7h. h's will go to 0, and the answer is 14x. So f prime of positive 3 is 14 times 3 is 42. F prime of 5 is 14 times 5 is 70. So now at number 5. F of x is equal to a negative 7x squared plus 2x. A is equal to negative 1 and 4. F prime of x is equal to limit as h goes to 0 of negative 7x plus h squared. plus 2 times x plus h minus quantity negative 7x squared plus 2x. We'll divide it by h. They're not asking for the formula this time, just the answer. X plus 2h plus 7x squared minus 2x h. X is limit as h goes to 0 if negative 7x squared minus 14xh minus 7h squared plus 2h plus 7x squared over h prime of x is limit as h goes to 0 of h times negative 14x minus 7h plus 2 over h. F prime of x is limit as h goes to 0 of h plus 2 so let that h term go to 0, left with negative 14x plus 2 for f prime of x. And then f prime of negative 1 is negative 14 times negative 1 plus 2. 14 plus 2 is 16. F prime of 4 is negative 14 times 4 plus 2 is a negative 56 plus 2 is a negative 54. All right, let's look at number 6. We've just got a couple problems left here for this video. This one's different because it's got x's in the denominator. X plus 5. A is a negative 1/2 and 2. So f prime of x is limit as h goes to 0, 8 over 2 times x plus h plus 5 minus 8 over 2x plus 5. And instead of dividing by h in the denominator, I'm just going to write divided by h like this. I'm going to put that h over 1 because I'm going to multiply by its reciprocal in just a second. F prime of x is limit as h goes to 0. We're going to make a common denominator in just a second. I'm going to put the 1 over h over here. Then I'm going to give myself some room here. 2x plus 2h plus 5. That has an 8. Myself some room. 8 over 2x plus 5. Some more room. We'll multiply here by 2x plus 5 over 2x plus 5. And here I'm going to multiply by 2x plus 2h plus 5 over 2x plus 2h plus 5 to make a common denominator. And I kind of covered up that minus sign, but it's still there. So f prime of x is limit as h goes to 0 of 1 over h times 8 times 2x plus 5 minus 8 times 2x plus 2h plus 5 over 2x plus 2h plus 5 times 2x plus 5. Simplify that numerator. f prime of x is limit as h goes to 0 of 1 over h times 16x plus 40 minus 16x minus 16h minus 40 over 2x plus 2h plus 5, 2x plus 5, f prime of x is limit as h goes to 0, 1 over h times negative 16h over 2x plus 2h plus 5 over 2x plus 5, h cancel with h, f prime of x is limit as h goes to 0 of negative 16 over 2x plus 2h plus 5 is 2x plus 5. The h in this term is going to go to 0, and that leaves me with a negative 16 over 2x plus 5 times 2x plus 5 is 2x plus 5 quantity squared. All right. Now I want to evaluate f prime at a negative 1/2, be a negative 16 over 2 times a negative 1/2 plus 5 quantity squared. Negative 16 over negative 1 plus 5 squared. Negative 16 over 4 squared. Negative 16 over 16 is a negative 1. F prime of 2, a negative 16 over 2 times 2 plus 5 squared. It's a negative 16 over 4 plus 5 squared. Negative 16 over 9 squared is negative 16 over 81. Right? Number 7. This one's a more difficult fraction. But let's go ahead and work through it. F of x is x over 6x minus 7. A is 0, and then a is 1. So f prime of x is limit as h goes to 0 of x plus h over 6 times x plus h minus 7 minus the original x over 6x minus 7. And then I'll just do times 1 over h. F prime of x equals limit as h goes to 0, 1 over h times, and I'm just going to write this out here as x plus h times 6x minus 7 minus x times 6x plus 6h minus 7 is what that simplifies to right there, over 6x plus 6h plus 7, sorry, minus 7 times 6x minus 7. Close that up. F prime of x is limit as h goes to 0, 1 over h times 6x plus 6h minus 7, 6x minus 7, 6x squared minus 7x plus 6xh minus 7h minus 6x squared minus 6xh plus 7x. All right, so everything without an h in it needs to go to 0. Some of the things with h's in them might go to 0, like 6xh and minus 6xh. So f prime of x is equal to limit as h goes to 0 of 1 over h times negative 7h over 6x plus 6h minus 7 times 6x minus 7. H's will cancel, and that leaves me with f prime of x is limit as h goes to 0 of negative 7 over 6x plus 6h minus 7 times 6x minus 7. Each terms go to 0. Here is a negative 7 over 6x minus 7 squared. So let's go ahead and plug in 0 into the derivative. That will be negative 7 over 6 times 0 minus 7 squared is a negative 7 over a negative 7 squared. That will be a negative 7 over a positive 49 is a negative 1/7. F prime of 1 is negative 7 over 6 times 1 minus 7 quantity squared. And negative 7 over 6 minus 7 squared is a negative 7 over negative 1 squared. So negative 7 over 1 is a negative 7. All right. This last one for this video has a square root in it, and that makes it a little bit more complicated. I think we did some of those when we did f prime of a. Let's look at f of w here. Is root 4w minus 3. So let's just break this down into f of w plus h. It's root 4 times w plus h minus 3. F of w plus h is root 4 w plus 4h minus 3. So f of w plus h minus f of w is root 4w plus 4h minus 3 minus root 4w minus 3. This is over 1. I want to rationalize this expression before we go any further. I'm building to my limit here, so just bear with me. Multiply by the conjugate of this, 4w plus 4h minus 3 plus root 4w minus 3 over root 4w plus 4h minus 3 plus root 4w minus 3. So that makes f of w plus h minus f of w equal to 4w plus 4h minus 3 minus 4w minus 3 over root 4w plus 4h minus 3 plus root 4w minus 3. Let's simplify that numerator of w plus h minus f of w is 4w plus 4h minus 3 minus 4w plus 3 over root 4w plus 4h minus 3 plus root 4w minus 3, and f of w plus h minus f of w is equal to a 4h over root 4w plus 4h minus 3 plus root 4w minus 3. So now we're going to divide by h. We'll say f of, let's go ahead and just put it all in there. F prime of w is now equal to limit as h goes to 0 of divide this by h and multiply by 1 over h. It's going to be 4 over, those h's canceled, 4w plus 4h minus 3 plus 4w minus 3. H's are going to go to 0. F prime of w is 4 over 2 times root 4w minus 3. And then 2 goes into 4 2 times. It's 2 over root 4w minus 3. 2 over root 4w minus 3. I don't think they rationalized the answer. No, they did not. So let's go ahead now and say f prime of 1 is 2 over 4 times 1 minus 3. 2 over root 4 minus 3, that's 2 over root 1. 2 over 1 is 2. F prime of 3 is 2 over root 4 times 3 minus 3 is 2 over root 12 minus 3. 2 over root 9 is 2 over 3. And that's where we'll stop for this video. We'll come back next time and talk about 3.2, objective 3, where we obtain the graph of the derivative function from the graph of the function. See you for the next video.